This video goes over examples of graphing sine and cosine transformations. So A is our amplitude. K is related to the period using the equation 2 pi over K. Our C value is our phase shift, which is the same as the horizontal shift. And the D value is the vertical shift, which we can also call the equation of the axis, sort of the middle value of the graph. So here we're just going to state our properties based on the equation. So the amplitude is our A value, that's the value in front. We can do the same thing over here, value in front. Our period, we're going to first identify our K value, which in this case is 2. And then we're going to find our period by doing 2 pi divided by K. Then our period is 2 pi over 2, which is just pi. Here, our value is also 2. So our K value is 2 as well, which means that our period is pi. The phase shift is the number that is beside the x. In this case, there isn't a number beside the x that's inside the argument of the cosine, so our phase shift is 0 or none. And our vertical translation is the last value right here, which is down because it's negative and then 12. On our right-hand side, our phase shift might be tempting to say right 6. It is to the right, but in order to get the correct value, we have to factor first. So we've got sine 2x minus 3, and then plus 8, which means that our phase shift is actually to the right by 3. And then our vertical translation this time is up 8, which is our number and sign at the very end. So in terms of our mapping notation, I am expecting you to plot 5 points when you plot a sine or cos graph. Sine starts at 0, 0. At pi over 2, it's equal to 1, a maximum. Goes back down through pi, through -1, and back up to 2 pi. So our base points for our parent graph are 0, 0, pi over 2 and +1, pi and 0. And then we've got 3 pi over 2 and -1. And then finally we've got 2 pi and 0. Cosine, the key points are 0 and 1, starts at a maximum, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and finally 2 pi and 1. So you do need to know the shape of those graphs in order to be able to graph them effectively. So let's try graphing this one here. We've got 4 sine x plus 2. So the first thing I'm going to fill in before I even graph are my characteristics. So my A value is 4. My period I know is 2 pi because there's no K value. My phase shift is 0. And my vertical translation is up 2. So I'm going to put a couple things on, and I'm going to talk about 2 different ways to graph this. So the first way I'm going to do more conceptually. So I'm going to put on my equation of the axis, which is right here at y equals 2, because that is my A value. I also know that the period hasn't changed, so that means that my key points of sine, the x values, are the same distance apart. So 1, 2, 3, 4. I'm going to label this. It's important to label your axes, especially as we're dealing with changing signs or changing scales. And so I'm going to use 4 boxes to represent pi over 2. So that means 8 boxes represents pi. 12 boxes represents 3 pi over 2. and 16 boxes represents 2 pi. So the only thing that's happened to my graph is that my y values have been stretched, but I know that my starting and my end point are at the same spot as the parent graph of sine, and I know that they're 2 pi apart. So I'm going to put my starting point on the equation of the axis. I'm going to put my ending point 2 pi later, also on the equation of the axis. Then I know that for sine, my middle point is also on the equation of the axis, and it's halfway between the start and the end. Now I know that sine is divided up into 4 sections, so that means that my maximum point has to be halfway in between 0 and pi. So that's at pi over 2, and my amplitude has to be 4. So I need to go up 4 from my equation of the axis. So 1, 2, 3, 4. And I know that my minimum value is going to occur at halfway in between these points. So I'm going to go down 4. 1, 2, 3, 4. Then I know what sine looks like, so I'm going to connect those dots and know that it satisfies those values. After I graph it, I can fill in these remaining parts. So my domain is in between 0 and 2 pi because I'm only graphing one cycle. I know that my range is going to go from -2 to positive, 2, 3, 4, 5, 6, to positive 6, because that's my lowest y value to my highest y value. My increasing intervals are happening at the beginning of sine, so from 0 to pi over 2, as well as from 3 pi over 2 to 2 pi at the end. And then my intervals of decrease are happening in the middle, from pi over 2 to 3 pi over 2. I can also graph this using the mapping notation, where I start with xy, and I know that my only transformations right now are happening to my y coordinates. I'm using the 5 key points that I have from my parent graph, and I'm going to apply the transformations to them. So I would get 0, 2, pi over 2, 6, pi and 2, 3 pi over 2, and -2, and then finally 2 pi and 2. So both methods work. Okay, let's try one more example here. We're going to identify our amplitude as the number in front. The negative just means that we have a reflection. Our period is still 2 pi because we don't have a k value. Our phase shift this time is pi over 3 to the left. And then my vertical translation is going to be 0. I'm still on my equation of the axis. And then my second row, I'm going to fill in after the fact. So if my equation of the axis is still the same, which is here, I know that my phase shift is going to be pi over 3. That is what I'm going to use to make my my scale on my x-axis. So I'm actually going to make each box worth pi over 6. So that means that 2 boxes are worth pi over 3. So I can label them here. I've got pi over 3. 2 more boxes would then be 2 pi over 3. 2 more boxes would then be 4 pi over 3. 2 more would then be 5 pi over 3. And then 2 more would be 6 pi over 3, which is 2 pi. And so I'm going to stop there for now, and then I'm going to keep going here. So let's figure out our first point for cosine is normally right at 1. But I'm going to move it to the left by pi over 3, and I want my amplitude to be 3. So now instead of being 1, my amplitude is going to be 3, so I'm going to go up 1, 2, 3. So then my starting point now is right here at this point, minus pi over 3 and 3, so that my amplitude is 3 based on that graph. So now I'm going to go 2 pi later, so minus pi over 3 plus 2 pi to get to my answer. Changing that into a common denominator means that I get 6 pi over 3. So I know that my endpoint for my graph is going to be at 5 pi over 3 at that same maximum value. Now my intermediate value is halfway in between. So graphically, I can count those squares. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means 5 squares must be in the middle. 1, 2, 3, 4, 5. Which then I can see I've got my middle point right here. My middle point is going to be down 3 below that equation of the axis. So 1, 2, 3. Okay. Now I've got a point that goes through, but I'm going to stop here because I've forgotten to add one thing. This negative sign is important. That means that instead of starting at a maximum, cosine is going to start at a minimum. So I'm going to move this value. The x value is still the same, but I'm going to move it down 3 below so that now it's starting at a minimum. I'm going to move my red point that I have here up to where my maximum value is that I was counting before. And I'm going to move that right up here to be in between those values. And then finally, I'm going to move this last point down here at 5 pi over 3 so that it's now finishing at a minimum. So I've got that reflected value. The last part that I have to do is find these intermediate points. So I can see that between these two values, I need the point on my equation of the axis to be halfway between, or a quarter of the way into the cycle. So I've got 1, 2, 3, 4, 5. So that means that I must have my middle point right here at pi over 6. Okay. I think I've got this point in the wrong spot here, so we'll move it up. Okay, and then I'm going to have another point right here. So I'm now looking for my distance in between 2 pi over 3 and 5 pi over 3, which is then going to be at 7 pi over 6. So 1, 2, 3, 4, 5, 6, 7 pi over 6. And I see what's happening here, the struggle that I'm having with my scale on this right-hand side. So I'm going to relabel it. And I'm going to say that every 2 should be pi over 3. After 1 pi over 3 comes 2 pi over 3. And after that comes 3 pi over 3. Then we've got 4 pi over 3. And then we've got 5 pi over 3. I could tell that my scale was off because of the fact that my graph wasn't looking symmetric. So I do have minus pi over 3 to 5 pi over 3. Those are my ending points. Then my point that is actually in the middle between those two is going to be, let's see, I've got 2, 4, 6, 8, 10, 12. So that means 2, 4, 6 would be my middle point. And then now I'm trying to divide each of those sections into half again. So the first one is here. And the second one is going to be, so I've got 3 squares. I've got 6 squares in between here and here. So my next point is going to be 3 squares there. So I've got 1, 2, 3, which is right where I had it drawn in the first place. Now, when I connect those dots, my graph is going to look symmetric, shifted, and stretched. So the last thing that we'll do here is fill in our domain. So our domain is going from minus pi over 3 to 5 pi over 3 because we're only graphing one cycle. Our range is in between minus 3 and 3 That's our lowest value of y to the highest value. And the intervals of increase this time are the first half of the graph. So minus pi over 3 to 2 pi over 3. And then the intervals of decrease would be from 2 pi over 3 to 5 pi over 3. You are sliding down on the second half.